Okay, we're going to be looking at hexadecimal. Now, if you know much about computers, you'll know that computers tend to work in binary numbers. They do work in binary numbers. And binary numbers are where we've got ones and zeros. And that is the series of ones and zeros are what a computer processes, and all data that a computer will process will come in binary. So this is binary. We work in decimal, so that's when we have like numbers 4, 6, 2, 1, 5, etc., etc. This is decimal or denary. Now, there's another type of number system called hexadecimal. And this is base 16, where denary, which we use, is base 10, and hexadecimal is it uses the digits 0 to 9. So you could have like 2, 0, 9, but then it has letters from A to F. So you could have A, F, and that would be a hexadecimal number. Now, we're going to do a wee review of basic of binary numbers. So let's say we had the number 256. Now, primary school maths, this is your hundreds, this is your tens, and this is your units. This can be rewritten as 6 times 10 to the power 0 added together by 5 times 10 to the power 1, and then 2 times 10 to the power 2, which would, I'm going to really just do overkill here so you understand, reviewing the whole idea of place value. So that would be like 6 times 1, which is 6. This would be 5 times 10, which is 50, and this would be 2 times 100, which is 200. So there you've got your units, 6 units, 5 tens or 50, and 2 hundreds or 200. If you add those all together, you get 256. So this is the whole idea of the decimal system. When I say base 10, so the units is like the 10 to the 0, tens are 10 to the 1, and the hundreds are 10 to 2. If we had thousands, that would be 10 to the 3, and so on. And that is the foundation of our number system that we use. It's really, because it's a base 10 system, it makes it really easy for us to get to grips with. The binary system is base 2, and the hexadecimal is base 16, which means if we, well, down here I'll show you the binary table first. So each time, so for you'd have 1, then you double that to 2, double that to 4, double that to 8, double that to 16, and so on. That's our binary table, and then we can use that to convert binary and decimal. But that's in the hexadecimal system, we've got 16 to the power 0, which is 1, 16 to the power 1, which is 16, 16 to the power 2, which is 256, and 16 to the power 3, which is 4096. And that's that would be, we'll come back to this in a minute, but that just shows you how, when you're using a hexadecimal, a base 6 number system, the different place values for that. So bear that in mind, but let's look at why hexadecimal is used for when we're talking about computers. So the computer doesn't read hexadecimal, it reads binary, but we can read hexadecimal more readily because it has less, it's not just ones and zeros in a big long line, it has more characters, which makes it more user friendly. So let's think of the binary, the decimal equivalent, and then the hexadecimal over here. So we're going to go through them from 1 to 15. So this is 0, and that's 0 for all of them. I'm just going to write them out there. 1, 0, 0, and that would be 1, 0 for 2, 0, 0, 1, 1. I'll just write them all out first and I'll come back in. 1, 0, 0, 0, 1, 0, 1, 0, 1, 1, 0, 1, oh no, 0, 1, 1, 1, 1, 0, 0, 0, 1, 0, 0, 1, 0, 0, 1, 0, oh, that's meant to be a 1 there, sorry. 1, 0, 1, 1, 1, 1, 0, 0, 1, 1, 0, 1, 1, no, sorry, 1, 1, 1, 0, and then 1, 1, 1, 1. So that's 1, 2, 3, I should have done it all together. 1, 2, 3, 2, 3, oh, 0, sorry, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. And in hex, they're all the same. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, oh sorry. Up to get to 9. So then at 10 you have A, then B, then C, D, E, and F. So if you have in hexadecimal the number FF is 15, 15. Now remember how we had, this is 16, and think of place value again, this is 16 to the 0, this is 16 to the 1, so you would take 15 times 16 to the 0 is 15 times 1, which is 15, and then 15 times 16 to the power 1, which is 16, and that is 15 times 16 is 240. Then you add these together, that would be 255. So FF in decimal is 255. Now, let's think about in a computer system data comes in bytes, and a byte is 8 bits long. So let's just think about a byte of data. Let's just take 10011101. This would be a byte of data, and we say that these little groupings of 4 these are nibbles. But if you think about, we have just used all the hex digits to represent all the possible nibbles. So we've written down every possible combination of zeros and ones here. We find that there's 16 of them, and they're represented by all of these. So if we look here, 1001 is the same as 9, which is 9 in hex, and 1101, so 1101 is the same as 13, which is D. So this here, this string of binary 10011101 in hexadecimal is 9D. So basically you can take any string of binary, and if you put it into little groupings of 4, you can find, by using this table, what the hexadecimal equivalent is. And that is the power of hexadecimal. Now, what is more tricky is taking a decimal number and converting it to hex. So we're going to do that. We're going to have an example. We're going to use the number 1551, and we're going to convert it into hex. So let's think about our table again. Let's think about, we have 16 to the power 0 is 1, 16 to the power 1 is 16, 16 to the power 2 is 256, and we won't need it, but 16 to the power 3 is 4096. Now, just like if you were doing decimal to binary, now 1551 does not go into 4962, but it will go into 256. So if we take 1551 and divide it by 256, you'll need a calculator. You'll get 6 and a remainder of 15. So here, because we've divided by 256, this, I'm going to put line under, so it's going to be our hexadecimal number. You're going to have 6 of the 256s. Now, so remainder 15, so 16 will not go into 15, so that's going to be a 0, but 15 is one of our hexadecimal numbers. 15 is the same as F in hexadecimal. So 1551 is the same as 60F in hexadecimal. Okay, let us now consider how to go from hex to decimal. So we're going to consider the number 1AB. So I'm just going to write this in underneath our table up here. So we've got 1. So what I'm going to do is change colour of the pen so that we can just so that we don't get the workings of the two muddled up, can we do it on the same page here? Let's just change pen colour. So let's think the number 1, A, B. So the B, when we think about the previous hex, is the same as number 11. So that's 11, and we times that by 16 to the power 0, which is the same as 11 times 1, which is 11. A is the same as 10, and we're doing it to times 16 to the power 1. 16 to the power 1 is 16, so it's 10 times 16, which is 160. And then 1, which is just 1, times 16 squared, which is 1 times 256, which is 256. Now we add these three numbers together, and if we add them all together we get 427. So 1AB is the same as 427. So I hope that helps.